We're solving problem 18 from the 2019 AMC12A. A sphere with center O has radius 6. A triangle with sides of length 15, 15, and 24 is situated in space so that each of its sides is tangent to the sphere. What is the distance between O and the plane determined by the triangle? So, say we have example, a ball and a triangle with lengths 15, 15, and 24, and place it on top such that the triangle rests on top of the ball. Basically, it's gonna be suspended in midair. We take a look at it from the top, and we have points A, B, C, O, which is the center of the sphere, D, the point where the radius of the circle touches the triangle, aka point of tangency, and we know that the angle that it makes with one of the sides of the triangle is 90 degrees, because that's how tangency works. And we know that R is equal to the length of the radius. So then what we can do is, we know that the entire length of this portion of the triangle is 24. So if we split that in half for, say, BC, this side will be 12. And we see here 12 and 15 combined with the right angle forces the last side to be 9, because ABC, triangle ABC, is a 3, 4, 5 triangle. So we can say that AC equals 9. We then see that the figure BDOC is a kite, so that means that BC is equal to BD. So if we want to solve for this AD, we do that. AD is equal to AB minus BD. Therefore, plugging in values, we know that the total length of the slant AB is 15. And we subtract from it 12, because BC is BD. And since BC is 12, we subtract 12 from the 15 to get that AD is 3. Then we can also solve for this length AO, which is from, there should be a space. If you enlarge it, you have this circle. It should be about a space this high. So it's including this space, because this point at the tip of the triangle is not a point of tangency. However, there's a point of tangency around there. So it's a longer distance. And we notice that what we want to do is we want to eventually find an equation for if we want to find an equation for radius, which is going to help us a lot. So we want to find the length of AO. Well, AO, again, we can do the same thing here, is AC minus OC. AO is equal to 9, because the total length is 9, minus OC, which is a radius of the circle, so R. Then, because DAO triangle, that one, DOA, is a right triangle, we can use the Pythagorean theorem. So we have AD squared plus OD squared is equal to AO squared. Therefore, 3 squared plus R squared is equal to 9 minus R squared. This is pretty simple now, because the R squares cancel, and then you can just solve for R, because there is no R squared in this equation, giving us R equals 4. The radius is 4. So what now we can do is, well, the problem asks us to find the distance between O and the plane determined by the triangle. So basically what it's saying is that we need to do like a distance formula. We need to do a distance formula. So it's if it's the distance between the triangle and the plane, we do the radius of the circle, or the radius of the sphere, which is 6, square root 6 squared minus 4 squared in terms of positioning. This is going to be equal to 36, square root 36 minus 16, which is square root 20, or 2 root 5, which is our answer for this problem.